Hello everyone. So here we are, we're in Tinkercad now, and for our first step of making this etched acrylic, we're gonna go from Tinkercad to EstlCAM to gSender, and that's it. You just press go on the machine and you are cutting. Once you've done this process a few times, making these things literally takes about 5 minutes, and that's just depending on your design. If you want to get a little bit more impressive and detailed in your design, obviously spend all day on that. But if it's a basic design you can do quickly, then this whole process is so fast. The only time consuming part is your design. So let's go to create, and we're going to hit a new 3D design. And just for time's sake, I'm going to make something quite simple. Maybe a name and a squiggle or a scribble or something like that. So let's do it. Now, when you're working in Tinkercad, this is going to be the basis of your design. Well, you want to make sure that it's the right size. Once we're out of Tinkercad, it's annoying to change the size. So just go ahead and make the size exactly how you want it here. When you're working in Tinkercad, also remember, in case your block of acrylic or whatever it is that you're CNCing, a piece of wood, a board, whatever, you're gonna have to put clamps on it. So you might want to leave a little bit around the edges, a little bit of space for those clamps and things. So we need to think of a name here. Let's go with an old-fashioned name. Here we go. It's a daisy. Let's do sans mono. Nope, doesn't really work with daisy. That might work. How about this? Whoa, definitely not doing braille. No thanks. Alright, so we're going to stick with sans. Now, you don't need to do this. It's just been a habit of mine. I tend to make everything about 2 millimeters, and that way there's nothing hiding behind these tall letters. For example, there might be something that is connected or pushed together or something that's kind of hiding back there. And when it's thin like this, just 1 or 2 millimeters, then I can pretty much see everything just the way it's gonna be. Obviously, you can do that. You can look around, but it's good for me. I like to do it this way. Now, let's go ahead and add a bit of design. I don't really want to go ahead and look through our shapes for flowers, but I'm sure there are some in there. You might be able to search and find something. The problem is, if I put a flower in there, it should definitely be a daisy, since the word is daisy. So I'm going to leave that out. I'm going to go back to our basic shapes. I'm going to give daisy a star, and again bring the height down 2 millimeters. And now we're going to do this a couple of times, so we can do the Control C and V, copy and paste obviously. And I don't want any one star to be the same as the other, so I'll just rotate them and stretch them out. I'll even stretch them out in different ways that not quite perfect. Alright, now if you're good with your mouse, you might be able to scribble something in case we want a, I don't know, cute little face or whatever it is that you want to do. I like to use my drawing pad for this, but it's not plugged in on this computer at the moment, so the mouse is gonna have to do. There it is. There's my self-portrait. Looks pretty good. Alright, back down to 2. Alright, there is our super simple design for today. Again, put as much work into this as you want. The better your design, obviously, the better your project is going to be. Alright, now, very, very, very important. First I want to group these together, but after that, I also want to make sure that the size is correct. Now, my work that I'm working with, the material, is about 100 by 100 millimeters. So this, if I click on these handles, it's only 56 by 82. So I'm going to go ahead and make this a bit bigger, and I'm going to leave some extra room at the bottom because the acrylic is actually going to slide into the bottom case. It's a 3D printed case, and I need some acrylic to kind of stick down inside there. Alright, so now we're at, what are we at, 95? I'm going to go with 94, and then we'll do the width. We're at 140, see down here, 132, 120, 110, 107. Alright, so anywhere in this range, I'll be okay. And in this case, we got what, 94, 94? There it is. Alright, that will certainly fit on my work material. Now, if you want to do the full 100, you want to go right out to the edge, you can put your clamps on the top corners, the bottom corners, and I think you'll be alright. I mean, clamping to the CNC machine, of course. Alright, so nothing is floating. Everything looks to be okay. And again, it's all grouped together, so I'm not going to export this in tiny pieces. Let's change the name. What are we doing here? Tinkercad to CNC. Is that what's happening? I think so. Alright, there it goes. Now when you want to export, obviously click on export. And for this, if we're going to 3D print, maybe STL, but for us, we're going to do an SVG. It's a laser cutting profile. And when we go ahead and save this, stick this, I'm going to stick this on our desktop and call it Tinker to CNC. There it is done. So let's close Tinkercad, and we're going to need to find gSender. Nope, sorry, EstlCAM. We're not at gSender yet. Okay, in EstlCAM, go ahead and get the file opened. So obviously, file and open. Tinkercad to CNC. There it is. There's my file. Open. Alright, now please read through these things when it gives you messages. There's a lot of pop-ups and things that are super helpful with this software. It's not terribly, it's easy to use at first, but the pop-up tips, the tool tips really help a lot. So I highly suggest you read through these things. Now in our case, we're going to use millimeters, and DPI of 90 is okay. Adjust to width, it's 94 millimeters, just like we expected. Alright, now notice that you can adjust the width, but not the height. So this is why I'm saying it's better to make sure the size is correct in Tinkercad and be done with it. Okay, so click OK, and here it is. Now the first thing I want to do is select with the select tool. I'm going to select everything, and I'm doing this only to test that all these parts are selectable. Notice that they changed color. They went from black to red. That means they are selected, and I just want to know, I want to make sure that this design is going to work. There's times where you put things in and the software doesn't quite see it, or it doesn't come out correctly, or there's holes, there's gaps, there's bumps in it, and by a quick selection you can kind of see all that stuff. So are we making a part? Are we drilling holes? Nope, we are engraving. Alright, so let's do that, and we're gonna manually select all these shapes. Sorry if your project has 400 little shapes, you're gonna have to manually select all of them. Go ahead and do that. Select every path. And that's it. I've tried the automatic selection, and on occasion it works, but I normally have to resort to the manual selection every time. Alright, now down here we have a bunch of settings that you want to select in case you are doing something a bit more complicated. You can have different tool changeouts and things like that. Now up here at the top is what we're most interested in. This is our tool, and this is the tool name. It's a round 1mm. I just did that because I have a round tool inside of my machine, and it's 1 millimeter, so I just called it that. And the size of it is 1 millimeter. It's a really small tool. I just want deep, but I want thin lines. So that's the tool that I chose. Most people would use a 2 or 3 if it's going to be an acrylic desk sign. If it's going to be something out in the front of a shop, maybe 5 or 6 rounded millimeter tool would work really well. If you have questions on what size tool you should use for what application, send me a comment and I'll let you know what I think. Now this is the depth per pass, how deep the tool is going to go each pass. In our case, we're going to do 1 pass, but there are occasions where you might want to do several passes, and that's the depth per pass. I'm going to go down 1 millimeter, not far at all. This is the angle that's called the plunge angle. If you want your tool to go in at an angle, it will do that for you. If you have a super short tool path, it probably won't work. For example, possibly maybe this little circular thing over here, the dot on the eye. I think that might work because our tool is so small, 1 millimeter. But if you have little dots and you're trying to go in at an angle, sometimes it doesn't work. Now this is the feed rate. This is really important. This is how fast your machine will go. I mean, do you really need to rush it? I don't suggest it. I use 90 millimeters, which is really conservative. It's really slow, but I've never had broken parts. I've never had problems. My tools aren't dull. It just works for me. The plunge feed rate, how fast it goes into the material, I set it at 80. This is, again, very slow for most people. This is the RPM of my spindle, and I've always had 10,000, which has been perfect for wood, soft wood, and as well as the acrylic and other types of plastics. You might mess around with this in your case if you're getting like really hot spots, or you're getting smoke, or you've got wood and it's burning, it's blackening. If it's blackening, you might want to go faster. It's sitting on there too long, building up excessive heat. And now this is the depth per pass. In case we're finishing something, you're going to go in and then in again, and then in again. You might want to go and use that setting. All right, but for us, that's pretty much it. It's all set up. So all you have to do is save the CNC program. And again, we're going to use this Tinkercad To CNC. Click that. Now, this is the last thing that you really have to be worried about. This is your cutting depth. This we've already set up here, but this is going to just kind of double check. Make sure it's correct. Alright, once it's done, now we've got a preview. When you click OK, it'll send you to the CNC control machine software. But in our case, let's go ahead and run the check. I highly suggest that you run the check because you might find something that goes off a little bit strange, or you missed a part, or it's not cutting a part. Another thing that might happen is it's incredibly inefficient, meaning it's going from the left side all the way to the right side, back to the left, back to the right, back to the left, adding travel time into your cutting. And you can go ahead come out of this, go back in and ask it to save again. When you click save, it'll draw these tool paths and it'll create the CNC G code. And every time you save it, you get a different version, slightly different. So you might be able to run it back through again and get a better version the second time. So I'm going to speed this up and see that it goes all the way through. It's cut everything. Looks good to me. So we click OK, and then now we're ready for our cutting software. So open up gSender. Now we need to load a file, and we got that Tinker To CNC, and there it is. There's our file. Looks pretty good. And so what we need to do first is obviously connect to our machine. I'm using a USB connection. It's on COM6. Let's see if we get connected. There it is. Alright, so first I suggest you zero your machine And what that means is you're going to go down to the very bottom left corner of your material and go ahead and put your spindle right at the top of the material, just barely touching your material. So you're just going to jog left and right, up and down using your X, Y, Z's. When you're finally right where you want, go ahead and drop your spindle down right at the top of your material. Go ahead and decrease the steps as you get closer and closer to your Z. And then once you're there, hit the 0 button. And then stand up, go check your machine, make sure it's exactly where you want it. Alright, once you're done, make sure you've clamped everything well, and go ahead and hit the outline button. Now what you want to do with the outline is make sure that this is going to follow all the way around the outside of the work. It's not going to go off the material, it's not going to hit a clamp, and nothing bad's going to happen. So you're going to click outline, just check the machine. I highly suggest you stand up, go to the machine, make sure it's doing what it's supposed to be doing safely and not destroying itself on a clamp or going off of the edge. Alright, after that, you click the start button and away it goes. That's it. That was all there is to it. And like I said before, if you've done this a few times, this project will go, the process will go faster and faster. And the only thing that you have to spend time on is your actual design. Indeed, you could do this at a market, right in front of people. You could sell these signs or engraved pieces of wood with their names on it. You could put it in little picture frames and stuff for stands on their tables. You know, you go ahead and get their design, do it right in front of them. It only takes 4 or 5 minutes, less than that if you've done this a few times. Let them go shopping, come back 10 minutes later, their project was ready and waiting for them. Something that you can do online as well. You can sell these projects online. Lots of cool things that you can do with this. Alright, hope you enjoyed something, learned something. I'll see you in the next one.